Repetition statements. Repetition statements are statements that repeat a group of code while its condition is true. Repetition statements are also known as loops. The first loop we're going to cover is while loops. The format is while parenthesis condition parenthesis curly braces with code inside. This should look very similar to an if. Alright, over here we have a flowchart. How flowcharts work is arrows show movement of code. So we move in and reach a condition. And diamonds represent conditions or choices. So off of a diamond usually you'll have two arrows come off. If the condition is true, we go one way. If the condition is false, we go another way. So we come into our condition. So we come into our loop, we look at the condition. When the condition is true, we do the statements inside the loop, kind of like we would with an if. But the weird part is, we go back to the condition and look at the condition again. If it's still true, we do the code a second time. And this loop can keep happening multiple times, over and over and over and over and over. When the condition is false, we come off and we do statements after the loop. Now, when you come in, if the first time you reach the condition it's false, we never do the code in the loop. That's why it can run 0 times, all the way up to infinity. In theory, if the condition is always true, you would have a loop that would run an indefinite number of times. So, while loops run 0 to infinity times. Alright, so we have an example of a while loop. Here we're going to start off, x equals 0. Is x less than or equal to 10? Yes, it is. So we print x, which is 0, and then we change x to be a 2. Then we come back to the condition. Is x less than or equal to 10? Yes. So we print 2. Then x changes. It becomes a 4. Is 4 less than or equal to 10? Yes. So we print it. 4, and then we change it to a 6. Is 6 less than or equal to 10? Yes. So we go in, we print it, we change it to an 8. Is 8 less than or equal to 10? Yes. So we print it and then change it. So now it's 10. Is 10 less than or equal to 10? Yes. So we print it. Then we change it. It's now 12. Is 12 less than or equal to 10? No. Our final output is 0 through 10, all on their own lines. Well, 0 to 10 by 2's. Our next example, we say system.out.print x is a positive number. So we want them to enter a positive number. Let's say they enter 8. Is 8 less than or equal to 0? No. So we never see this code, and we would move on to any other part of our program. But let's say they entered -2. Well, it says positive number, so let's mark this out. So, yeah, positive number. Hold on. Let me erase that. We're already moving. So, positive number would be something greater than 1. So let's say they entered 0, that maybe they don't know what a positive number is. So, if they entered 0, the loop would activate. Is 0 less than or equal to 0? Yes, it is. So it would say invalid input, and it would tell them to enter a positive number. And they're like, what? That's weird. Let me enter -1. Is minus, then it would come back around. Is -1 less than 0? Yes, it is. Invalid input. They're like, let me try 3. So then they put in 3. Is 3 less than 0? No, and it moves on. So this code would force the user to enter a positive number before it could progress. We're going to now be looking at do-while loops. The format for a do-while loop is do, curly brace, code in a loop, while, condition, semicolon at the end. It's weird, it has a semicolon back here. Normally ifs, while loops, other loops don't have semicolons. But this is do, curly brace, while, condition, and there is a semicolon at the end. Alright, do while loops run 1 to infinity times. So this is different from a while loop in the fact that it runs at least once. So this is how you can see it up here. Let's look at the flowchart to see how that works. We come in, we do the statements inside the loop. So we don't even look at a condition because there's not one. We do everything. If the condition is true, we do it again. If the condition is true, we do it again. This is where you have your loop. When the condition becomes false, we move after the loop. But notice, the statements happen at least one time because they happen before you check the condition. So do while loops run 1 to infinity times. Let's look at another example. So we make a scanner, This is similar to our last example. Oh, we make a scanner. I don't know why we're making a scanner. We don't really need that line of code. Int x equals 0. Total equals 0. So let's write x equal 0. Total equal 0. Total plus equal x. So add 0 to total, still 0. Make x bigger. X is now a 1. Is 1 less than or equal to 5? Yes. So we add that to total. 1. X becomes 2. Is 2 less than or equal to 5? Yes. So we add that to total, making total 3. X becomes a 3. Is that less than or equal to 5? Yes. So we come back around and we add 3 to it. So total would now be a 6. Then x becomes a 4 because of the x plus plus. Is 4 less than or equal to 5? Yes. We come back around. We add that to total. 10. X goes to a 5. Is that less than or equal to 5? Yes. So we add that to total, making 15. X becomes a 6. Is 6 less than or equal to 5? No. We're done. And then we print total, which would be 15, as our final answer. This one we did need the scanner. So scanner keyboard equals new scanner. X is a 0. This is just a rework of the other program. System.out.print, enter a positive number, x equals keyboard.nextInt. If that number is less than or equal to 0, we say try again. While that number is less than or equal to 0, we come back around and tell them to enter a positive number. This is writing that same code we did before to make sure they enter a positive number as a do while instead of a while. Alright? For loops. For loops are a little bit more complicated. For loops, we have initialization, condition, variable change, code and loop. This is all the stuff separated by commas, and they run 0 to infinity times. So you need to write down for loops run 0 to infinity times. How this works, the first thing we do, that's the wrong flowchart. We're missing one box. Let me fix this flowchart real quick. So we are missing a box for, I copied and pasted these from Word, and apparently I didn't highlight everything. Why am I writing enter? This is initialization. So if you want to copy down this flowchart, make sure you add this box. So we come in, we do the initialization step, then we check the condition. When the condition is true, we do the statements inside the for, then we change the variable, then we come back around, check the condition. If it's still true, do the statements in the for, change the variable, check the condition. So you'll see an example of how this actually works in a little bit, but make sure you copy down this new flowchart. So make sure it has the initialization step up there. I'm going to go to the next page, which should describe what each one of these 3 different pieces are, and then we'll see some examples. Parts of a for loop. Initialization sets the value for a counter. A variable can be created here. This part can also be left blank. The next part, we have condition, a Boolean expression to determine if the code in the for will be run. This part cannot be left blank, so you need to write down. This is the part that cannot be left blank. Variable change changes the value of the counter. The counter was created in part 1. Doesn't always have to change the counter. It can change other things. But for our simple for loops that we're going to be doing, we're always going to be changing the counter variable. Any variable change is valid here. So that means you can change other variables. This part can also be left blank. So the initialization and variable change can be left blank. The condition cannot. I'm going to walk you through how this stuff works on the next 2 slides that we have examples for. Here's our first example. This is very similar to the other program we already ran. So here I'm going to say x equals 1, and hold on. What really should have happened first is total equals 0. Total equals 0. Then the initialization step always happens first. Then we check our condition. Is x less than or equal to 5? Yes. So we add it to total. Then, from now on, we always do the variable change, which is right here, and then check the condition. The variable change says x plus plus, so we change x to a 2, and then we recheck the condition. So after we go there, we go here. Is x less than or equal to 5? Yes, 2 is less than or equal to 5, so we add a 2 to total. Then we go up to the variable change, making x a 3. Is 3 less than or equal to 5? Yes, we add it to total, giving us 6. Then we do our variable change, making it a 4. Is 4 less than or equal to 5? Yes, so we add it. We get 10. And then we go x plus plus. X goes to a 5. Is that less than or equal to 5? Yes. Total goes to 15. X plus plus. X goes to a 6. Is 6 less than or equal to 5? No, it's not. Then we say int average. Should have wrote AVG. It's really painful writing average out. Equals 15 divided by 5. If there are 5 elements, because there were 5 items that were added to the total. So 15 divided by 5 is 3. And then we would print the average of your number. The average of numbers 1 to 5 is plus 3. So it would say the average of numbers 1 to 5 is 3. Our second for loop answer. Here we're writing a loop to calculate a power. Instead of using math.pow, we're manually calculating it. We have answer, and that equals 1. We have base, that equals 2. We have power, that equals 3. Then we have a equals 0. And basically what will happen is we're going to do 1 times the base, times the base, times the base, times the base, until we've done 2 to the power of 3. So we start off, is 0 less than power? Power's a 3? Yes. So answer equals itself 1 times the base, which is 2. So answer becomes 2. A gets a plus plus, becomes 1. Is 1 less than power? Yes. So we're going to do this code again. Answer equals answer times base. 2 times 2. 4. A becomes a 2. Is 2 less than 3? Yes. So answer becomes answer times base. So 2 times 4, 8. Power goes to a 3. Is A less than power? No, they're equal. So it would have happened 3 times that we multiplied by the base, which was 2. So 2 to the 3. That's how we got 8. So here it would say the base is 2 caret power 3 equals 8, the power we just ran. Alright, the break statement. This command is used to stop the current iteration of a loop and then not... the command is used to stop the current iteration of a loop, that's the current run of a loop, and then the loop is not executed again. So here we have x equals 1. If you can perfectly divide x by 3, which you can't, break. Else, print x. So we print 1. X goes to a 2 because of the x plus plus. 2 less than 10? Yes. Can 2 perfectly be divided by 3? No. So we print 2. X goes to a 3. Is 3 less than 10? Yes. Can 3 perfectly divide 3? Yes. Break. Leave the loop and do not run it again. So our output here is 1, then 2. And we're going to stop here, and I'll splice in the last little bit for the last 2 slides, because I'm almost at 15 minutes. Alright, picking up for the last two slides, our next command is continue. The format is continue semicolon. This command is used to stop the current